Welcome back to another Q&A video, and in this video we are going to talk about where to go next, like what to learn next if you've learned a bunch of object-oriented programming and web development. So the question in this video is from Nicholas. So actually let me address you directly, Nicholas. Firstly, thanks a ton for asking the question. Great question. So, and I mean, since this is going to be a public video, let me actually just start by reading some of the stuff that you're outlining that you've done, because let me just say I'm thoroughly impressed by the path that you've taken. And I mean, I assume some of it is from, as you're saying, like it's from a technical program that you actually like, was it like a pre-university technical program, right? But even though the things that you've done, that it seems like you've decided yourself, like the books you read and so forth, that is like impressively good path. So I'm hoping that others might be inspired by the sort of steps that you've taken. So let me just briefly tell something about your question, or like read some of the parts from your question. So you're saying that you've read or you've recently graduated from a 3-year pre-university technical program. Kudos, man, great job. And then like you learn basic coding stuff, like arrays and branching logic and so forth. And again, like if you're watching and you're not Nicholas, maybe pay attention to the things that he's outlining, because I think this is a great outline for like stepping through and becoming a more advanced programmer. So anyways, after graduation, you were saying that you've read/studied the following books, right? One is Computer Science Distilled: Learn the Art of Solving Computational Problems. I haven't read this, but it looks like a great book, right? And then Clean Code, in order to, in your words, lay the bricks right? It's a good move. And then planning and making sure that you lay the bricks in the right place. So you did Applying UML and Patterns, an Introduction to Object-Oriented Analysis, and Design, and Iterative Development. And then currently you are reading Head First Design Patterns, and watching the video series that I have on design patterns. So, I mean, good stuff, right? And then you're saying along the way you've refreshed on video courses, like on stuff, on the stack that you have at your job, right? So C#, SQL, JS, JavaScript, CSS, and HTML. Yeah, and then like you're looking into the language runtime for C#, and you're reading Code Complete too. So, I mean, it's like you're actually sorry for reading this from your question, but you're saying it's gone very well for me, and I'm like, no surprise, man. You're really rocking this. It looks like you're really rocking this. So kudos to you. Good moves, great books. I think you're really approaching this right, and I think you're really approaching it right by thinking, okay, well, tactically, what's my next step now that I should do? What's the next thing I should read in order to sort of progress further? Let me just say, the TLDR, I'm going to vote for functional programming, but we'll get into like a bit more in the details of what I mean. But yeah, you're saying, so what should I do next, right? Your field is sort of web development, and you want to be as rounded as possible, but you also want to understand the nitty-gritty details of your tech stack. So, and then you're saying maybe it should be the Gang of Four book, right? Like the classic book on design patterns. So I think regarding the nitty-gritty, I am probably the wrong person to ask. So I'm going to take the other approach, right? I'm very much a person who appreciates high-level abstraction, right? Who's like, okay, well, there's a thing above the thing that we're talking about now, and to become better at the thing that we're doing, we can learn the thing that's above the thing that we are doing right now, right? It's like increasing one level in the abstraction, in my mind, it's like an incredibly valuable thing to do, because then you can sort of look down on the thing that you were doing before and say that, the thing that I was doing before is actually an instance of this more general idea. And now I have this general idea, so I can think about how other instances of that general idea would look. And that's when you sort of get, in my mind, it seems like you reach a point where it's easier to switch languages, and it's easier to switch stacks, for example, right? Because most things are the same, right? And you just exchange some keywords for some other keywords, and even if it's not like you're switching like essentially the same language, like if you're moving from C# to Java, right? It's like essentially the same language, because both are statically typed object-oriented languages. But even though, I mean, or I mean, I guess that's step one, right? But then it's sort of like a one-to-one conversion. It's like, well, I'll just exchange this keyword for this keyword, and like this detail doesn't really exist in Java, or this Java detail doesn't really exist in C# or whatnot. But even on a higher level, right? When you start to identify that, okay, but what I'm dealing with is a statically typed object-oriented language, and these are the characteristics of static typing, and these are the characteristics of object orientation. And then like, okay, but then you also have, for example, functional programming, and then you have dynamically typed functional programming and statically typed functional programming. Okay, but I can use the lessons that I've learned from statically typed versus dynamically typed when learning functional programming. Okay, and then I can use like maybe that doesn't really make any sense, but I was going, or I mean, you can use that when going into statically typed versus dynamically typed functional programming. And of course, then as you learn functional programming, you can use those key points in different functional languages, but also in, for example, the functional parts of C# and Java, right? So like many of the, sorry, now I'm going into detail at once, but like so many of the commonly used languages now, such as then C# and Java, are slowly, I mean, I shouldn't say slowly, I have no idea about that, are introducing concepts from functional programming, and have been for a long time, right? Because the concepts are great. So LINQ, for example, in C#, right? It's essentially a primitive version of functional programming, right? Where you're sort of chaining a bunch of method calls. In some sense, like it's like you're composing a bunch of functions, but sort of not really, right? But like you're passing data through a bunch of functions. Yeah, it's more like a pipeline where you start with the data first. There's a different word for that, but it's escaping me at the moment. Anyways, so here's what I would suggest, right? Let me just think if I wanted to say something else before. No, okay. So I would say, I think you're reaching a point where I mean, at surface level, it looks like you're really maturing, right? And actually, I mean, you're saying I've only been programming for 18 months. That kind of makes me ask, like, what have I been doing with my life for the last 18 months? That's huge, man. You're making serious progress. Anyways, I would say functional programming. I would say the golden grail, that's the word, right, is statically typed functional programming. So essentially, for example, Haskell, right? That's the target, right? That I would say, have that in mind, because I mean, okay, let me just say as a precursor, I'm by no means some kind of expert in functional programming, right? I'm totally learning this like right now, right? But it just seems to me that as I'm learning more Haskell, it becomes evident how it's, let's say, more expressive than many other languages. And again, you can think about the things that other languages do, or the patterns in other languages, and you can say, okay, but in Haskell I would do this and this. And in Haskell it's usually trivial, right? But then you think about what would be the equivalent in, let's say, object-oriented C#, and then you're like, okay, but like that would be tricky. And that's an incredibly useful lesson, right? And not only as a theoretical exercise, I would argue, because again, the argument is that more languages or let's say the lines between different paradigms are being blurred, because people are striving, or like language designers seem to be striving for making languages that are useful rather than languages that sort of strictly follow a single paradigm. So even if you're now operating in C#, I mean, C#, I guess, will have more and more functional programming building blocks in it, right? And I guess we'll sort of start to look more and more like functional programming if functional programming happens to deliver on the promise that it's sort of promising. So yeah, I mean, that's sort of the kind of rationale behind why I would suggest functional programming. But I wouldn't say, unless you really want to, right? I wouldn't say just dive into Haskell, right? You might want to dive into Haskell if you want to, right? Then there's this book, Learn You a Haskell, which is free online. And I think it's fairly great. Like, it's very approachable. But maybe like you seem like a fairly pragmatic person also. So if you want to approach it sort of in a way that's that always keeps you productive, here's the sort of path I would suggest. I would suggest, I just jotted down a few notes before I started recording this. I would suggest starting with JavaScript with no I was going to say no notes because I talked about notes, but I mean JavaScript with no libraries, right? So try to learn functional programming in JavaScript, because that also like aligns with your stack, and that means that you can use whatever you learn immediately, right? You can use it in your stack and you can use it in production. So try to learn functional programming concepts, learn to write JavaScript in functional programming style without introducing any external libraries. So I haven't read this book, but I just did a few Googles, and then I found, let me bring up this browser. So what's it called? Professor Frisbee's mostly adequate guide. Oh my god. Functional, whatever. Let's not type this whole thing. We're going to find it. So Professor Frisbee's mostly adequate guide to functional programming, right? Let me actually put it up on Goodreads here. So you can see it has 200 votes and 4.4 in score, right? Professor Frisbee's mostly adequate guide to functional programming. And in my understanding, he's doing this without external libraries. So this just kind of seems to me like one example of a good book. Let me see if we have... Yeah, never mind. I mean, you can read through this. This is just one suggestion, right? Off the top of my head. But that seems fairly sensible. But something to guide you in learning functional programming in JavaScript. This is also like this dude, Brian Lonsdorf. I think he has a video series somewhere. I can't remember what this is. It like Egghead or something like that, right? Somebody mentioned somewhere. I think here they mentioned that. Yeah. He has a course on egghead.io. So maybe use that, right? But anyways, so something like that, to trying to get sort of comfortable with the idea of function composition, for example. And actually, I mean, so like again, like I have this series on game development or functional programming in game development using JavaScript, and I'm actually like thoroughly enjoying using JavaScript to write functional programs, right? Because it's, again, like the dynamic nature of it sort of removes all overhead. And of course, you're not writing the most sort of safe programs, but it's well fun, right? Like for sure, well fun. Okay, so that's step one, like JS with no libraries. Then I would jump into JS with libraries. So functional programming in JavaScript, but using libraries, just to sort of see like, okay, because like maybe you've been watching my series on Ramda, for example. So one example of such a library would be Ramda, another would be Folktale, and like I guess the target here is to sort of work through practical examples until you can read the Fantasyland specification. Actually, let me just go Ramda, and then what did I say? Folktale, and Fantasyland specification. So Ramda, cancel. Okay, Ramda documentation. Actually, so here is actually my introduction to Ramda, but I wasn't necessarily referring to that. I was referring to, well, this is my video as well. Wait, Ramda YouTube. So yeah, so here these purple videos, right? Like I have a bunch of videos on Ramda. So Ramda JS tutorial, and then I have tons of parts. But maybe you've already seen this, right? But maybe you could work through that. But I mean, since you seem like a person who's very comfortable reading books, then I would suggest read a book instead of watching my videos, right? Because that's probably going to be way faster if you're actually like, I was going to say capable. I don't mean capable, but if you're comfortable reading books, right? I'm a very slow reader, right? So it takes me a very long time. But if you're a fast reader, do it, man. Of course it's better to read books, of course. Okay, but anyways, Ramda.js, that's one example. Folktale, that is a... No, Wikipedia Folktale. Yeah, GitHub Folktale here, okay. Hello, GitHub? Yes, okay, like that. So those are two examples of, yeah, wait, Folktale, generic functional programming in JS. Yeah, actually, let's go to this. Oh, this is very cool. They have multiple repositories. I have never been to the GitHub page of Folktale. Yeah, here. I've only been to this page, actually, right? So here, Folktale, a standard library for functional programming in JavaScript. Ramda, a practical functional library for JavaScript programmers. The thing with these, right? The reason I'm saying these is that these are, I don't know if they respect, but at least like they are aware, like thoroughly aware of the Fantasyland specification. So these guys are doing JavaScript libraries or functional programming libraries for JavaScript that are made by developers who truly understand functional programming way better than I do, right? But it seems like when you're learning these, it's like it clicks because it's working in the same way that functional programming works in, for example, Haskell, right? So it's like you learn something in Haskell and then you check it out in Ramda, for example, and you're like, oh, okay, well, this is like it's the same thing, right? As opposed to, for example, underscore and Lodash, right? So underscore and Lodash isn't really, I mean, it's been years since I looked at that, so maybe it's completely different now. So I shouldn't bash on them. But there's this video. What is that video called? Underscore your score you're doing it wrong, right? Is a video. So I would suggest watching that if you want another, like here, hey underscore you're doing it wrong. So that's a video where they emphasize why they're missing parts, such as, for example, currying in these libraries. Hang on one moment, I need to let the cat in. Okay, sorry about that. Let's keep going. So let's not get stuck on this, right? But anyways, like I'm saying, it's all libraries, all functional programming libraries are not created equal. So and again, like there's this Fantasyland specification, which I guess is a way of trying to harmonize the design of different, or the APIs of different functional programming JavaScript libraries. That's sort of my interpretation of the Fantasyland specification. But what I mean is that, like in step 2 here, where you're learning functional programming using a library in JavaScript, I would sort of see like the goal being to be able to understand this Fantasyland specification. Actually, that's one of my own goals, right? Like I understand parts of it, but definitely not everything of it. But anyways, and this is like the theory part. If you, like, again, like depending on how pragmatic you are as a person, if you feel like you're making stuff work and you're being productive and you don't want to learn the theory, don't worry about it, dude. Just stay productive, right? Don't worry about this specification, for example. But anyways, not all libraries are created equal. So for example, I wouldn't do underscore, I wouldn't do Lodash. If you want to get into statically typed functional programming, I mean, maybe you would have you could have a look at TypeScript, but I mean, I spent a little bit of time with TypeScript, but that was at the same time as I was learning Haskell, and then very quickly I reached a point where I can't remember exactly what the problem was. I think it's like types in regards to, or like type inference in regards to higher order functions, where it just sort of broke down on me in that it wasn't able to infer the type, or like catch errors in regards to the types that, or catch type errors at the level of sophistication that I was expecting. And then I was like, but this is pointless, because of course I'm not writing, of course the point of functional programming is to be able to abstract your programs, but if the type system falls apart on me when I'm expressing my programs at a very abstract level, then what's the point of having them, right? So like, I would not worry about TypeScript, for example, right? Similarly, Elm seems to be a much more comprehensive solution, but now it escapes me what that blog post is called. But there's a blog post criticizing, it's probably saying something like, Elm, you're doing it wrong as well. It's wrong. I don't know, maybe something like that. Yeah, Elm is wrong, right? I'm not saying this dude is right. I don't know, right? I don't know. But like, he makes some, or she makes some very interesting points in regards to how Elm is not abstract enough, right? It's like you're getting some parts of statically typed functional programming, but you're really not getting the best parts, or like you're really not getting some of the crucial parts that you would need in order to express really really abstract languages. But I mean, now we're deep into the stuff. The reason I'm saying is just that it's better to learn something which doesn't teach you, let's say, strange habits or something like that. So I would not say that Elm is I don't know, actually. Let's just say, I mean, I don't know enough about Elm, but I would say that Elm is a good thing to learn. TypeScript is a good thing to learn. I would not bother about getting into underscore. I would not bother about getting into Lodash. But if I can choose between Elm and what was I about to say? Yikes, I just forgot. Anyways, my point is I would choose Ramda or Folktail. Actually, I just realized now there's also PureScript, right? So, also I messed up my points. Let me stick to the script instead of making stuff up on the fly. Okay, let's do it this way. Step one was JavaScript with no libraries. Step 2 was JavaScript with libraries. I would say Ramda and Folktail. Dig into those, right? It's super easy to be pragmatically productive immediately, right? You can just jump into them and use them. And then let's segue into the third point, right? Step 3 is to get away from dynamic typing and moving into static typing, right? So probably you're familiar with dynamic typing and static typing, right? Because like you've been working in C#, which is a statically typed object-oriented language, like mostly, or like maybe I don't know originally, but like mostly, like the core of it is object-oriented and it's statically typed. Whereas JavaScript, I guess, like I would argue, is a functional, dynamically typed language. I guess like it's a floating scale, so it's like, I mean, has classes now, so you can write object-oriented JavaScript, but like you had prototypes from the beginning, and then I guess it was more like a functional language because if you don't use prototypes, it's functional. Anyways, so step 2 is like dynamic languages, right? Then it's like JavaScript with libraries, dynamic functional programming. Step 3, okay? Then, actually, I wrote here I would get into, for example, Elm. Okay, let me rephrase my argument. I would get into Elm, or I would get into Reason. Let's look at that. Reason. Oh yeah, I clicked the link here actually. Wait, stop. Yep, damn it. Sorry, dude, who ended up on the video. Anyways, okay, Elm is wrong. Okay, Reason ML, and then actually I realized also there's PureScript. So let's Google PureScript as well. So we have Reason, and we have PureScript. Let's compile to. Let me just read this because I can't remember. Strongly typed functional programming language that compiles to JavaScript. I think this is Haskell based, right? Yeah, actually, let me change my mind. Maybe this is stupid. Let me not. Okay, any of these, right? Let me, instead of using the Elm is wrong page, use actual like Elm's page. So I would, when getting into statically typed functional programming, I would get into Elm, Reason, or PureScript. And if I chose now, like for myself, I would do PureScript. Like I would try to do the thing that mostly resembles Haskell, or that resembles Haskell the most. And spontaneously, I would believe that that's PureScript. Maybe I'm wrong, right? Because again, like Haskell is sort of the golden mean, where it's my understanding that it's there are a few pragmatically useful languages that are as expressive as Haskell, right? I don't know, like maybe Lisp should be the golden mean, but I don't know enough about Lisp to say anything about that. But anyways, number 1, PureScript, number 2, Reason, number 3, Elm, in that order, for like step 3 when you're getting into statically typed functional programming. There was one thing I was about to say. Yeah, I can't remember. Anyways, and then finally, then like step 4 is Haskell, like, right? Learn you a Haskell is one book. I remember now what I wanted to say. Sorry, for step 3, where we're talking about Elm, Reason, and PureScript, that trio, no, actually there's another language. Anyways, the thing I remembered is that there's a guy called Brian Marek? Marek, statically typed functional. So let me just Google this, programming. So I think, yes, here. So I'm actually reading this book myself. I'm not sure what state it is in now. I think he's writing it, but he's come pretty far. Is there like a progress bar somewhere? No, I don't know. But anyways, I mean, here, An Outsider's Guide to Statically Typed Functional Programming. Maybe there are tons of books that are better. I don't know. It's just I've been reading this one, and it's not bad at all, right? Like, it has a lot of good examples, and it's covering a lot of interesting ground. Like, I mean, everything from like compositions to like, yeah, like function composition, currying to lenses. So like, it's a it's a sensible book. And also, like, the reason he's calling it an outsider's guide is that it's he's sort of trying to be non-theoretical, right? Or it's like he's trying to be pragmatic, and it's like, I don't know how much of an academic he is, but like he's essentially trying to be pragmatic rather than being one of these people who are like super theoretical and then just alienates everyone. Sorry again. Wait, cat troubles. Okay, let me try to wrap this up. So, I mean, that's one suggestion for step 3, where we have Elm, Reason, and PureScript. And then step 4, I mean, Haskell, right? So there are probably a lot of other books. I would say there's nothing wrong with this book. Learn you a Haskell for great good, right? And I mean, you can read this online, and it's free. So actually, let's go Learn You a Haskell Goodreads. Let's just see what people are saying about that on Goodreads. For great good. Sorry, my cat. Oh my! So my cat is trying to Google for things. Okay. Yeah, 4.33, 134 ratings, right? I mean, it's like people seem to be appreciating this book as well. So I mean, I'm not just being silly. But yeah, I mean, that's one good suggestion for learning Haskell. And yeah, I mean, in some sense, my understanding is that Haskell is really not just this theoretical language that people in academia use to research things rather than actually do anything that's pragmatically useful. So I'm using Haskell to express simulations for my work, but then again, I am an academic. But again, there are tons of videos on YouTube where people show practical things that have actually been built using Haskell. And in some sense, I think, I mean, PureScript is probably an attempt to bring Haskell to the web, right? To the front-end web, I guess. Or, I mean, it doesn't really matter. But yeah, I mean, I just, like, now I'm guessing, right? But I would just guess that we're going to see more and more of Haskell everywhere. Because as you start to get into it, there are just all these moments where you're like, whoa, well, like, that's much easier, right? Like you can really express very complex things very, very easily. Actually, let me end on this note. I found this was interesting. I haven't actually read that blog post, but as I was just scrolling through a bunch of stuff before this video, I skimmed this article, Elm is Wrong, that we talked about before, and then there was this link. This is gonna take too long for me to find. Was it actually in here? Have you ever scrap? Yeah, it was in regards to tuples, right? Tuple. Anyway, the real thing. Yeah, I think I'm gonna have to drop this. Heard of? No, here, zero. No, it's not that one. Yes. Okay, let me drop this. There was another. I just skimmed another article which was talking about how everything looks. What was it? Like, it's difficult to see how something is greater when it's sort of above your current knowledge level, right? So, for example, like, proper Haskell is above my current understanding, right? But as I move into proper Haskell, right? And that language is in some sense in an in a sort of hierarchy of abstraction, it's above other languages. Then from the venture point of Haskell, or from the perspective of like knowing Haskell, looking down on other languages, you can see how they are more complex, in the sense that it's more complex to express the same ideas as you would express in Haskell, right? But they are more simple in that their building blocks are less abstract. So this is kind of back to the idea that we talked about in the beginning, where we talked about like again abstraction. Like as you learn an abstraction, you realize that things that you knew before were not abstractions but instances of this abstraction. And that's a really useful thing to learn, right? Because when you know the abstraction, you're able to move freely between instances, or not necessarily freely, right? But with less friction between instances, as opposed to if you don't know the abstraction and try to move between instances, because then when you move between instances, everything just looks like a completely new thing, right? It's like I'm trying out this language or this library or this framework or whatever, and it just looks like a completely new thing. And then I try out this other thing, and like there's almost nothing in common between them. But as you learn the abstraction, right, and then you try these things, you're like, it's more trivial, because you're like, oh, okay, well, I mean, this thing is like this thing in the other language, but, right, with this exception, right? Or like, this thing is an instance of this general idea, which I already know, but like with this particular nuance of such and such, right? In the same way as that, again, like if you're moving between dynamically typed object-oriented languages, who cares? It's no big deal, right? Ruby, Python, And if you're moving between statically typed object-oriented languages, C#, Java, who cares, right? And if you're moving between, let's say, statically typed functional languages, then, I mean, this is not as great of a comparison, but like OCaml and Haskell, they're similar, right? But you can more easily identify the differences. And it's my understanding, I don't know OCaml a lot, but like my understanding is that there are a bunch of differences, such as, for example, functors being a completely different thing in OCaml, which then, has consequences. I'm not sure if they have type classes. But anyways, now this is a total sidetrack. So abstractions, man, right? Like, and of course, let me just finally say that when I say abstraction and instance here, I just mean that metaphorically. I really do not mean that in the object-oriented sense. I mean that sort of in your mind, right? Like learning the abstraction of an idea allows you to move freely between instances of that idea, right? Let me end on that note. Super good question. I hope this was a bit useful for you, and I hope that you're not really. I hope that you really don't want to. No, I hope that it's not the case that you really don't want to get into functional programming, because maybe then the whole video is useless. But I highly encourage you to get into functional programming. Hope it was useful. Thanks a ton for the question. I hope to see you again on the channel. And thanks a bunch. If any one of you want to ask the next question, do check out the links in the description for where you can post questions. Thanks a ton, and I will see you in the next one.